In the previous videos, we have discussed two examples of research design, as demonstrated by the flowchart here, as well as the flow diagram here. The two research design was designed on basis of the simplest model of one-to-one, and it was mentioned the significance of having an optimum research design without overlapping and redundancy. The two designs have a common characteristics where every single part of the research serves a significant purpose throughout the entire research. This gives you an overview how a research is carried out. Let's say now you have worked out your own research design, which after several revisions you are satisfied and you find it to be achievable. Next, you will need to work out the details, how the research is actually carried out. You are still at the planning stage, knowing the major process of the entire research. However, the details is yet to be established. You might need to work out a data collection plan for you to have a better idea and pictures on what you can do, serving as a guide for you in carrying out different stages of your research program. Let's say now we use this as an example. There will be preliminary study, parametric study 1 and 2, and analytical studies. These constitute three major components of your research, which are designed to attain three objectives of your research. These stages of studies are listed here, and then you will have to gain a better idea how you're going to conduct all those studies. Each stages of the studies is with the purpose. Therefore, you will need to know the purpose of those studies so that your following actions will be designed in accordance to the purpose. You may ask yourself some questions regarding the purpose of those stages of the study. These are the answers that you would like to look for. For the preliminary study, you might want to know whether the design performs well, whether it is workable, or which design performs the best among several different designs. Assuming that you have several different designs here, and there is possibility that there are more than one design is workable, or all the designs are workable, but you are unable to tell which one is the best. Of course, you are looking for the best design for you to go for the detailed study. Therefore, your purpose of the preliminary study is for you to determine which design is the best to be carried forward for the parametric and the analytical study. As for the parametric study, your purpose is to investigate the behavior of the specimen, responding to several significant parameters. Through extensive review of the literature, you have identified 4 important parameters that you need to study. Knowing those parameters going to lead to significant impacts to the performance of the specimens. And also you know that those parameters may be also used to fill the research gap, which you can contribute to the pool of knowledge. Let's say now you have identified 4 parameters to be studied, and then you will do it in the parametric study 1 and 2 for any 2 of them until all the 4 parameters are covered. As for the analytical study, your ultimate concern is the model reliable? Then from the flow chart here, you know that this preliminary study and parametric studies are all experiment. Therefore, you should have the planning in order to conduct the experimental tests. You need to determine what kind of data that you intend to collect from the experiments. Let's say now in this case, you are testing for a beam. You would like to know the load acting onto the beam, the displacement as measured from the deflections of the beam, the strength of the reinforcement bar, as well as the failure modes of the beam. Knowing the data that you need to collect, then you have to decide the instruments to be used. You will need a hydraulic jack in order to impose load onto the specimen. You will need data logger for you to monitor and store the data. You will need load cell for you to measure the load. You will need LVDT for you to measure the displacement. And you will need strain gauge for you to measure the strength in the reinforcement bars. You might also need camera for you to snapshot in order to show the failure modes of the specimen. Now you have the list of the instruments identified. You should theoretically check with your respective lab. Make sure all the instruments are available. You might need to estimate the quantities that you need to be checked against the inventory in your laboratory to ensure those stages of the study can actually be conducted. You can acquire those informations from the laboratory by referring to the technical personnel, such as the technicians. And then you will need to have an idea regarding the operations of those testing, how the specimens are to be set up, how the testings are carried out, when to start and when to end the testing. Maybe you can define the operational definitions. It means that when do you need to consider the operations? From the start, which is when you start acquiring the first reading, or when you start applying the loads onto the specimen, you will consider the experiment started. And how do you consider the experiment ended? It is when you observe the failure of the specimen. Now, how do you know that the specimen has failed? There should be a clear definition of failure of the specimen, which you can observe from the readings of the load cell. You see at least 3 consecutive drops of the loads reading as given by the data logger. Then you know that the specimen has failed and the load resistance of the specimen cannot reach higher than what it has achieved. Also, you might need to clearly specify the sampling parameters, which in this case, for your preliminary study, your intention is to know which design is the best. That means your sampling parameters, it will be the design shapes of the specimens. As for the parametric study 1 and 2, you are studying 2 parameters in parametric study 1 and another 2 parameters for the parametric study 2. And you might need to clearly work out the precautions measures. This is also important to you because you would like to conduct your experiments so that it gives you reliable results for your investigations and discussions. The best way for you to do so is finding the relevant standards regarding the testing and strictly follow the recommended procedures given by the standards. Those standards can be BS, ASTM, or others. Normally, this kind of standards give you a clear idea how the procedures was carried out. It also tells you the apparatus required for the testing, as well as the positions of the measuring instruments recommended by the standards. Some also give you some guides how do you analyze the result. Therefore, if you are doing the experimental tests, you are strongly recommended to comply with the relevant standards. Sometimes your testing programs are quite custom designed, which you cannot find the exact standard covering the design. You may refer to the standards which is doing a similar type of testing, adopting the principles behind the procedures, especially the precautions procedures, in order for you to minimize the possible errors as acquired from the experiments. The baseline gives you additional information regarding the testing. What are the units that you use in terms of your study? So your unit now, it will be quantified by numbers of tests carried out. What are the possible defects for your study? Or how do you know that your testing now cannot be used? It is when you do not acquire the data or your data is incomplete. Knowing this defect, it will give you a judgment whether you need to redo the experiment. And the opportunity here represents the number of specimens. Let's say now you are testing for the full-scale beam. It is rather troublesome to produce the big-scale beam, and it incurs costs for the specimens. It is not economical for you to have 3 specimens for one identical design. Therefore, you will have one opportunity. Knowing that you only have one opportunity, then you have to control the quality and the workmanship from the start until to the end of the study. This includes preparing the materials which have gone through proper inspections. Make sure there are no visible defects. Make sure they fulfill the specifications as per your design. Fabricating the specimen in accordance to the standard procedures, complying to the industrial standards. Handle the specimen carefully, not to cause any undesired damages to the specimen before testing. Following the standard procedures as per recommended by the relevant standards. Using the calibrated instruments for you to measure the data. Always cross-check the functionality of the instruments in order to prevent incomplete data as acquired after you have finished your testing. You need to have a full imagination of how the research is being carried out, considering every single aspect of it throughout the study, in order to prevent any mistakes or errors that can affect your result. You know that only reliable result will give you valuable findings. Then later you proceed with the analytical model. Your purpose is to know whether the model is reliable. Of course, on top of that, later you will have to analyze the response of the specimen on basis of the analytical model later. Then you want to know what actually the analytical model is used for. What kind of result that the model tends to simulate, which in this case you are looking for the load capacity and displacement. That means the analytical model here will help you to determine the load capacity and displacement of the specimen based on the design of the specimen as influenced by all four parameters here. Then your study method, it will be derive the equations. There won't be any instruments involved, and your operational definition now will be the criteria for you to determine the reliability of the model. You want 80% of your model result with plus minus 10% variations from the experimental results. What you see here is, once you have complete filling this template for the data collection plan, you gain a better idea how your study is being carried out at different stages of your research. You may not need to present this in your methodology sections of your thesis. It is basically for your personal usage. Some may want to put this in their proposal reports during their proposal defense for their postgraduate studies to demonstrate that the entire research is systematically planned as a good impression to the supervisor and the examiner. This operational definition here provides descriptions to enable a common understanding and prevention of ambiguity. You will like your entire research here properly planned with a clear-cut definitions on certain things, so that you won't caught yourself in the confusions, making decisions on case-by-case basis, which can lead to inconsistency in terms of the operations that may to some degree affect your results. And these precaution measures, as given here, are the measures taken to ensure the consistency, reliability, and validity of the respective studies. You need the consistency here because later you will need to make comparison among different specimens in order for you to evaluate the performance of the specimens. In order for those comparisons to be valid, all the specimens should go through the same set and same standards of the experimental study. I see most of the students, they do not actually work out this data collection plan. Some may feel it's quite troublesome, and some might not be able to find the heads and tails of the studies that they would like to carry out. I would strongly recommend you to work out something like this. It will consume you some time, but it will save your hassle when you are actually doing the study at different stages of your study. In fact, for doing a research study, one of the important skills that you need to acquire, it will be how do you plan your research. That means all these are actually being worked out before the actual research is carried out. Imagine you are in the scenario when you are in the middle of preparing your specimen, done the test setup, and then realize that your lab do not have a certain instruments to do the measurement. Then you will find yourself caught somewhere in between the availability of the facility and meeting the deadlines. You may have sufficient funds for you to buy for the instrument, but this will take some time and it will cause you some delay in terms of your research progress. Also, with all the unexpected hassle that occurs somewhere in between your research study, it imposes you some pressure psychologically. You feel stressed out of so many things that you have to cover. Not only on the technical side, you have to spend much effort to understand that, and on the operation side, there are so many things that you need to coordinate. A research is a serious matter, especially for the experimental tests. You will involve a lot of instruments, a lot of precautions measures, and you will light your specimen, which in this case you have only one specimen for each design. You will have to do that one specimen perfectly right for the first time when you conducted the test. If any defects occurs, you will have to redo the specimen and reconduct the test. This is going to spend you some time. Don't forget that if you are dealing with the concrete, preparing the specimens is one thing. You spend some time to acquire the material, fabricate the specimen, maybe for 1 to 2 weeks, cast the specimen, and then you need to wait for 1 month for the specimen to harden, reaching to the mature age before you can proceed with the testing. This 1 month will cost you a lot in terms of the delays to your deadlines. And this is one of the main reasons most of the postgraduate students, especially those are doing the experiment, they spend more time with the experiment than what they have anticipated at the early stage. If you have everything well planned, the hassle will be less. Psychologically, you are more comfortable and stable, and most of the things are quite smooth because you have resolved them before it actually happened. And this is one of the skills that you would like to learn before you actually enter the working industry. Try this and you will observe the differences, and you can compare yourself with your colleagues who do not really plan ahead. And you will feel yourself so relieved that most of the problem you have planned ahead and resolved in advance.